have time to begin? Not that song, unfortunately. Oh, and who just made it in? Melissa, just in the nick of time. All right, no Anahi. Hopefully she'll be by in a minute. That's posted. That's running. Okay. Good afternoon, everybody. Today is going to be a very talky day on my part. I apologize, but it must be done. Last week was intense as far as content, right? We had that homework. Whew, has some tough questions in there, okay? So today we are doing the very important follow-up. I am going to go through all of these solutions to last week's homework, and I need you to follow along in your own work. So take out your homework from last week in whatever format you used. If it was on paper, look at the paper. If it was on the computer, pull that up on the computer so that you can see it. And if you only have the one screen, you'll be doing a lot of alt-tabbing back and forth. We'll try to read everything out for you so you can hear that. And be ready to ask questions, right? This is possibly the most important part of learning this content, is the feedback, confirming for yourself, yes, I got that one right, I'm on the right track. No, I got that one wrong. Okay, what did I do wrong? Why is it supposed to be that way and not the way I thought it? I'm going to try to explain as I go, but we've only got so much time. Some things I'm going to go faster on, some things I'll slow down. Stop me at any point and ask, hey, Mr. Apple, what about this one? Hey, what about that one? Can you explain why it's this? Anytime, because that is the entirety of today. All right, your class work task is to check if all your answers or all your questions have been answered. And all your answers should have questions. So without further ado, let's begin. Determine which of the following statements, are statements. So A, what's your name? There's a big fat question mark. Good sign. Nope, not a statement. It's a question. You did not have to include the explanation of why. I did that just on my end. B, the rain in Spain falls mainly on the plain, ends in a period. It's a sentence. Is it a statement? Yes, because I can say true or false in response to that, and it makes sense. Right? I could say, yes, it does, or no, it doesn't fall mainly on the plain. Mostly falls on the bushes. I don't know. Right? C, Happy New Year. Not actually a sentence. It's an exclamation. There's no verb there. No. D, 5 is an odd number. That's true. That makes sense. Yes, that was a statement. Three. Here we are taking these sets of symbols and rewriting them into full statements using the statements provided. Noticing that this guy means and. This arrow means if then. So I'll call that the arrow. This I'll call caret. Pretty close to the caret key on the keyboard. It's not positioned exactly right, but it looks like it. So I'm going to call it caret. This guy looks like a V. That means or. And the tilde means not. So those would turn into A, roses are red, and the sky is blue. Just like that. B, roses are red, and the sky is blue, or turtles are green. There's a couple different ways you can write this. These statements need to be in the same order. They need to be connected with the same words. However, exactly how you set it up, there's a little bit of room. I used a comma here to show that the roses are red is separate from blue sky, green turtles group, right? Because they are grouped in parentheses. Parentheses work very differently when you're speaking in English, or typing, I guess. They don't indicate a group. It's more of like, this is a side comment. So you can't put them together with parentheses here. So I set them off with a comma. You could also say, roses are red, and it is the case that the sky is blue or turtles are green. You could group them with that phrase, setting up, hey, incoming thing. That would work. C, if the sky is blue, then both roses are red and turtles are green. So that one, by nature of if, comma, then, you already have things set up into those two halves. So this gets grouped kind of automatically there. D, if turtles are not green and turtles are green, then roses are not red. Again, both of these phrases need to be before the comma. You do not have to repeat turtles. That is a slightly redundant. It would be perfectly acceptable to say, if turtles are not green and green, or if turtles are green and not green, you can actually reverse the order of the ands. That doesn't change the meaning. That's okay too. But otherwise, those all have to be there, comma, then roses are not red. Or roses aren't red. Contraction is always acceptable. Then it is not the case that roses are red. Could also be used. All right, questions so far? I'll give you another minute to write here. Got longer ones. Number 4 goes in the other direction. Here are written statements. We are going to translate them into symbols. So 4a, if it is raining, then the sun is not shining, should become Q, arrow, tilde, P. B, it is raining and the grass is green, should be Q, caret, R. C, the grass is green if and only if it is raining and the sun is shining. R, double arrow, Q, caret, P. We didn't talk much about the if and only if in class, but it was in your notes. I'm not going to ask you to use it as part of your own argument, but in this sort of context where you're translating, still recognize it. Okay? It just means it's a conditional that can go both ways. You could say, if R, then Q and P, or if Q and P, then R, both are true. The conditional and its converse are both true in this case. So we put them together and call it a biconditional. Trivia fact here, another way you can shorten if and only if you're writing out in words is IFF, if. And mathematicians recognize that as shorthand for if and only if. So we end up, so if you're not going full symbols, you can at least go shorthand if. All right, and then D, either the sun is shining or it is raining. P, V, Q. And do please note, by the way, when you are setting up your own symbols for statements, please do not assign one of them with the letter V for this very reason. That's not a letter V. That's the or symbol, which is typographically not exactly the same as a V letter. That's the closest thing we got on the standard keyboard. So don't confuse yourself by making it a variable as well. Okay. Pause for questions. All right, next section. Here's the tricky business. Given statement P is true, statement Q is false, and statement R is true, find the truth values for the following. P and not Q is true, because P is true. Q was false, but we said not Q, so not false means true. So true and true together make true, right? That's what we're doing here, working through piece by piece. How do these construct to make the net result? Your truth tables are going to be really handy here. It's a quick reference to just look up, oh, that combination makes this. Okay, got it. And you can have those. If they're in your notes, you can use them on the test. Continuing on, B. It is not the case that P or Q. All that is false. C. Not P implies R. That's true. D. If and only if not P and R, then Q. That's true. E. Not Q and P or R. That's true. F. P or Q if and only if R. That's true. G. R and not P or R and not Q. That's true. Finally, H. P and Q implies Q or not R. That is true. All right, what questions do you have from that one? They should, if they are not already correct, I want you to be in the position where you look at them, you see the correct answer, you go, I immediately understand why that is the case. If there is any hesitation, any confusion, if you are not 100% sure, yes, I see why that's the answer, ask me now. One feature I wish Zoom chat had, that a lot of modern chat clients do, is the little ... to know somebody is writing something, right? Wouldn't that be great? Because then I know somebody's like trying to ask a question, and I don't move on, and then the question pops up after, like, oh, they were too slow, because it was a big question. They had to do all this writing. Right? I just saw like a little dot, like, oh, someone is typing. That'd be useful. Otherwise, I got to come up with these silly little things to fill time, because really I just need to wait a really long time to make sure. But I don't want to just stand here silently for 2 minutes, you know, because she's fine. She's moving on. If she had a question, she'd have raised her hand. We do have the hand raise. I guess I could enforce that, right? Use the Zoom hand raise to know there's a question, and then I can pause, and then you can type it out. Maybe I should do that. I should think of that. We got to work smarter here. All right. I guess there's no questions because nobody typed anything or said anything. So let's go on. Number 11, we're finding the hypothesis and the conclusion in each of the following arguments. All right, these are very short arguments. They are the shortest possible. There's only one conclusion in each one. You could, of course, chain multiple pieces together and make one larger argument, much like we saw in My Cousin Vinny. Right? The whole sequence was actually this small argument plus this small argument leads to that smaller, argument. But in this case, we have all football players are introverts. That's one hypothesis. Tony is a football player. Another hypothesis. So, indicate a word. Tony is an introvert is our conclusion. B says Bob is taller than Jim. That's a hypothesis. Right? The reason it's a hypothesis, do you know it's true? At this point, you're relying on whoever's telling you this. Right? They are asserting that. Like, well, how do I know Bob is taller than him? Did you measure them? Right? That's how you can ask, right? How did you come by this information? Right? We determined it ahead of time through some other means that makes it a hypothesis. Or you arrived there logically from some other statement that makes it a conclusion. Right? So this one you had to measure. That's a hypothesis. And Jim is taller than Sue. We had to measure that separately. That's a hypothesis. But together, those two facts tell us, so Bob is taller than Sue. We arrived at that logically. It's a conclusion. We didn't have to do the measurement. Right? Usually, that's the point of logical arguments, is coming to conclusions that you can't, or at least don't have to, test directly yourself. Moving on. Speaking of arguments, make sure you are following one of the valid formats or your argument is no good. So we're going to check these. Are they any good? 13a says all professors are handsome. Gee, I wonder who could have written this book. Could it have been a professor? Some professors are tall. Therefore, some handsome people are tall. Okay, some handsome people. Are some handsome people also professors? They could be. We didn't eliminate that possibility. All the professors are handsome. So some handsome people would cover that. Some professors are tall. So those same some handsome professors are tall. That is valid. We got a little bit of syllogism there. And then you could also say a modus ponens going from some handsome people to tall. I'd say mostly law of syllogism, if you had to label it. Because the therefore includes both sides of the expression. Right? If people are handsome, then they could be tall. Right? Here we go. B, if I can't go to the movie, then I'll go to the park. I can go to the movie. Therefore, I will not go to the park. That sounds like a pretty reasonable choice. It sounds real-world accurate, but it is an invalid conclusion because you could go to the movie and go to the park. You didn't say you can't do both. You just said if you can't go to the movie, you'll do the other one. That doesn't preclude doing both. Right? If there is another possibility, it's always a good check. If there is another possibility, then you haven't come to the one and only valid conclusion. So whatever you got was invalid. It's not the only possibility. Same case here. If you score at least 90%, then you'll earn an A. If you earn an A, then your parents will be proud. You have proud parents. Therefore, you scored at least 90%. No. That is invalid. It sounds pretty good. Like all of this can be true, except is having that 90% the only way to get proud parents? No. You could have proud parents. Maybe they're proud of your performance at the sports game last week. Right? They are proud of, oh, you got your driver's license. Good job. They're so proud. Those grades, though, you got to work on that. Okay? We don't know. It's not the only possibility. Invalid argument. D, some ARPs are bombs. All bombs are certs. Therefore, some ARPs are certs. I have no idea what we're talking about here, but structure-wise, this is the law of syllogism. It's totally valid. E, all equilateral triangles are equal angular. All equal angular triangles are isosceles. Therefore, all isosceles triangles are equilateral. No, you can't do that. You can't just move backwards and expect it to still be true. That's what they're trying to do here. That's not valid. Either You negate things as you go backwards and call it modus ponens, or you go forwards and, negate things and call it modus tollens, or go forwards and call it modus ponens. But you don't get to just move backwards, right? If equilateral, then equiangular. The order matters. If you already know those terms geometrically, you can see it. Well, yeah, obviously, not all isosceles triangles are equilateral. Of course not. Easily come up with a counterexample to that guy. Bogus. F. If you work hard, then you will succeed. You do not work hard. Therefore, you will not succeed. People try to convince you of this all the time. Those are terrible people. That's an invalid argument. Working hard is not the only way to succeed, right? There's other ways. I guess really it depends on how you measure success, I suppose, right? Maybe you just sit at home playing video games all day, every day. Well, if you call that success and it's not hard work, well then congratulations, you're done, right? Maybe success is making a lot of money. Maybe you get lucky. A friend of a friend hires you at a place. You don't work so hard, but you move in there anyway. Like, it happens all the time. You could get lucky. G, some girls are teachers. All teachers are college graduates, required by law. Therefore, all girls are college graduates. No, invalid. It was so close, too. If you had said, some girls are college graduates, sure, because that's what we said. Girls to teachers, teachers to college graduates. Would have been a nice straight law syllogism. They tried to trip you up with that. All girls. I didn't say all girls. I said some girls. You can't just start overgeneralizing in the middle of it. Invalid. H. If it doesn't rain, then the street won't be wet. The street is wet. Therefore, it rained. Valid. That's a modus tollens right there, if I ever saw one. All right. Pause for questions. Yeah, I can also stop and get a drink, and that's another way to pad out the time there. No, all right. Next up, 15. Oh, this is a good one. We got to determine if P is necessary for Q, or is P sufficient for Q, or P is necessary and sufficient for Q, aka both, right? If it's 1 and 2, then we'll 1 and 2 make 3. Actually makes sense there. All right, let's try this. A says, P, Bob has some water. Q, Bob has some ice. Is having water necessary for having ice? You want to make ice. If that's your goal, what are the things you need? Do you need water? Is that on the need list? Absolutely. It's definitely necessary. You can't make the ice without it. We are, of course, talking about regular, plain old ice, right? Not dry ice. That'd be cheating. Okay. But is it sufficient? Can you make ice with only water? If I give you just a cup of water and say, here, make some ice, can you just do it sitting there at the table, no other tools, skills, objects required? No, you can't do it, right? You're going to need something else, probably a freezer would be my guess, right? So water is not sufficient to form ice. You need some way of extracting the heat. So water plus cold. So it just gets 1, or I. B, P says it is snowing. Q, it is cold. Okay. Is snowing necessary for being cold? If you want to go outside and conclude, yes, it is cold, does it need to be snowing? No, there's other ways, right? Like today, you can go outside, it's cold if you're not wearing a jacket, but it's not snowing. So it's not necessary. But is it sufficient? If you go outside, or not even go outside, look outside, look out the window and see that it's snowing, is that enough to conclude, yep, it's cold out there? Absolutely, right? You can't have snow without cold atmosphere, at least pretty high up. And then if it's too warm, even down low, it just melts and turns into rain, and then you don't get snow, right? So if it stays as snow while falling, it's definitely some minimum temperature out there, or some maximum temperature, right? Cold. So it's sufficient. 2, but not necessary. All right, C. P says it is December. Q says 31 days from today, it is January. Anywhere in December, doesn't matter which. All right, is it necessary to be December in order for 31 days later to always be January? Think about the extremes there. Is there any other point on the calendar where you could add 31 days, land in January, that did not start in December? I would look at the extreme ends, right? The middle of December doesn't make much of a difference. Let's look at the extremes. Okay? December 1st, 31 days later. December itself has 31, so December 1st, 31 days later is January 1st. I landed in January. I was in December. I moved back a day, November 30th. 31 days later, I'm on December. Shoot. November plus 31 doesn't equal January. Okay, what about the other end? December 31st plus 31 days, still in January. Obviously, if we go one more, January 1st plus 31 days, now we're in February. We went past it. So yes, December is necessary for 31 days from today to be January. And is that sufficient? Is that all we need to know to guarantee 31 days later is in January? Yes, for the same reason. Right? There is no other possibility. It is sufficient to conclude. If I'm in December, anywhere, 31 days later will always be January. All I need to know. Don't need to know which day. It happens to work because they both have 31. If December was only 30 days, this wouldn't work. You couldn't swap November, December with these. Questions there? All right, let's keep going. Now, specifically, which laws are being used in each of the following arguments? So we're going to assume they are already valid. We're not checking that. Valid argument. Which one are they using? 17a, if Joe is a professor, then he is learned. Not a very common word, but or used as such. Not learned, learned. If you are learned, then you went to college. Joe is a professor, so he went to college. That would be law of syllogism right there. If, of course, we're referring to just this last sentence, the whole last sentence, Joe is a professor, so he went to college. That statement is a conclusion by law of syllogism. If you wanted to break it down further and say, no, I'm going to say Joe is a professor, that's a separate statement. He went to college, separate conclusion. Then you also have modus ponens, or law of detachment, in there as well. We'll see the same thing on C. B, if you have children, then you're an adult. Bob is not an adult, so he has no children. So again, treating this whole line, right? Bob is not an adult, so he has no children, would be the contrapositive statement, so law of contraposition. Or if you break that up, we can call the first half a separate statement, Bob is not an adult, period. And then those hypotheses together would give us the he has no children conclusion by modus tollens. So a couple different ways to look at it. And C, same as A. If I am broke, I will ride the bus. When I ride the bus, I am always late. I'm broke, so I'm going to be late. Law of syllogism. And then could be broken again further, separate those to modus ponens, law of detachment. That's why it's called law of detachment. It detaches those two pieces. Oh, geez, I turned it sideways again. Get back over here. All right, 19, the other massive table of truths and lies. So this time we have statements A and B are true. P and Q, always false. X and Y have unknown truth values, dun dun dun. Which means some of these are indeterminable. Some of them though, even though X and Y are unknown, we can still figure out whether the whole thing is true or false in some cases, because it won't matter whether X and Y are true or false. This is where that truth table really comes in handy, because you can check all the possibilities. You can read off, oh, if X is true, then I'm on this line, it's true. And if X is false, oh, the whole thing is still true. It doesn't matter. So, down the line, A, if P, then A or B. That'll be true. B, if B, then P or A. Also true. C, if X, then P. Unknown. And this is where the unknown rears its ugly head. I don't know X. If X was true, a true statement leading to false conclusion, that's a false conditional. That's breaking the promise. You said if you did the thing, it would happen. You did the thing and it didn't happen. You lied to me. You can't have that. That would be false. Oh, but we don't know that. What if X was true? Okay, then it'd be, if X was false. If it's a false hypothesis leading to a false conclusion. If pigs fly, then the grass is red. You know what? Sure, we can call that true. Anything could happen if pigs fly. It doesn't. That starts out false. You can conclude anything if you start with a false premise. It doesn't make much sense, but we count it as true because it can't be proven false. So, but I don't know which one X is. So the whole thing is unknown. D, A or P. True. I get to pick the best one. Or it gives you the options. Always take the true one. E, if B, then Q. False. You broke your promise. How could you? F, if B, then X. Unknown. B started out as true. I don't know if I had held that promise or I broke it. Haven't determined. It's unknown. G, A and B or X. It's true. I don't care about the or X. I always get to choose B. It's guaranteed true, right? H, Y or X leads to A. True. I, Y and B implies P. Unknown. This is an and conjunction. They have to match. I don't know if this matches yet. J, A or X implies B and Q. False. K, X If X, then A. That one is true, because I have a true conclusion here. If X is true, true leads to true. Good job. But if X is false, false leads to true. We still count that as true. You didn't break the promise there. You started out as false. It never happened in the first place. It doesn't matter. L. X or P? Unknown. M. If not X, then X. Unknown. For the same reason. We don't know if this is a case like K or if it's a case like C. It's like extra unknown. I don't know if it's unknown or not, so we really don't know. N. X or not X. Always true. That's a pretty nice one to know. Right? I don't know what X is, but if I can pick between it or its negation, I can always pick the true version. Very convenient. O, however, Y and not Y, well, that's only true if they match. They're never going to match because one is always the opposite, no matter what Y is. So Y and not Y is always false. But I negated it, the whole thing, so we're back to true. Questions there? All right, here we go. I think there's but one more, the Euler diagram. Giant picture. I would say the best technique for these is to find your spot in the diagram and look, what circles am I in? So, all women, the whole circle, are mathematicians. Is this whole circle inside that whole circle? No, it's only got a little bit of crossover. That's false. Not all women are mathematicians. Ridiculous. Euclid was a woman. That's preposterous. Totally false. I mean, we only really know that because the dot here is not in that circle. Historical facts, not important here. We're saying from this diagram. All mathematicians are men. False. Look, there's some in the women, in the mathematicians. Crossover. All professors are humans. Whole circle, inside the whole human circle. True. Some professors are mathematicians. There's the crossover, that bit. True. Some are. Euclid was a mathematician and human. Euclid, inside mathematicians. All inside humans. Totally true. Okay. Final call for questions. You were tasked this weekend with writing up at least one question that could have been asked today. Maybe I already addressed it. If I did not, you should ask it now. If I did and you have an answer now, that is your task for today's classwork, is to write up the answer for your question. You should have seen it now. Although we've got, 6 minutes left, I do want to point out one more thing that I posted to Classroom this morning, and that is some examples of responses from Friday, the logical arguments from the movie My Cousin Vinny. And these are some proper logical arguments identified. I saw 2 major categories of mistakes on Friday. One was people just not including enough to make a full argument. They would quote one line and say, oh yeah, that's modus ponens. It's there needs to be more there. You have to have the conditional if, then, and restate the thing. So some of those, there weren't fully formed arguments to begin with. And then many of them were also invalid arguments. And that, well, you say this is modus tollens, but nobody negated the thing in this instance. So that that wasn't the case here. Or you set up your conditional wrong. So there were several mistakes there. So do please take a few more minutes sometime today. Check these. This covers most of the content from those scenes, most of the main ones, so it should probably match the examples you pulled out. I do want to draw your attention to a couple interesting ones here. We've got the classic, 5 minutes to make the grits. Then it must have been instant. He said they were not instant, so he did not take 5 minutes, right? That was like the very beginning, the first thing they concluded. Oh, guess you didn't take 5 minutes, right? It was a nice summary. I also liked, where was the other one? Oh, this one down here, MP. So modus ponens. If Vinny wants Lisa to explain, then he will say, I would love to hear this. Vinny says, I would love to hear this. Therefore, Vinny wants Lisa to explain. I love that someone was able to draw that out of the scene because that wasn't just the dialogue, right? They added the conditional there beyond what was said. So it's a nice example of ways to interpret something is going on. You read into it that Vinny wants Lisa to explain. Right? That's your understanding of, well, why did he say this thing? Because he wants this to happen. If you can say anything, this happened because that, you can write it as a conditional. If that, then thing happens. And that's what this person did here. All right, so lots of good further examples to refer back to because, spoiler alert, you will be tasked with writing more arguments in the future. Speaking of, quarter is almost over. We've only got these 2 weeks left, this week plus next week. And that's it, the quarter is done, which means our quarter test is next week, Friday. Start preparing for that, right? Get mentally ready for that. Oh, yeah, big test, right? All the logic stuff coming together. I will be preparing a review packet for you. It will be posted this Friday, so you have that nice long weekend to work on it. Okay? That'll serve as your review. So that's coming up. But we got one more task to do this week, and that is writing your own logical argument from scratch. Okay. Final questions, comments, concerns? No? Make sure you write up the answer for your question, post that on Google Classroom, and then you're done for today. There are the 2 sections on study.com for your homework this week, so not too bad. Lighter workload. Those are the logical fallacies. That's the fun stuff. I don't know why, but everybody always loves pointing out when people are wrong. Folks seem to take pleasure in that, so enjoy those. And with that, it's 1:39. We got less than a minute left.